It has now been 2 years since NASA's James Webb Space Telescope provided us with a breathtaking glimpse into the deepest and most distant regions of our universe. This groundbreaking $10 billion observatory is the largest and most powerful telescope ever placed in space, offering humanity an unprecedented window into the cosmos. Among its most astonishing early discoveries were images of a seemingly unremarkable patch of sky that, upon closer inspection, contained thousands of never-before-seen galaxies. These revelations forced astronomers to rethink their fundamental understanding of the universe's formation and evolution. One of the most shocking theories emerging from these observations is that the universe may be significantly older than previously believed. For decades, scientists have worked under the assumption that the universe is approximately 13.8 billion years old. However, new hypotheses based on Webb's data suggest that this might have been a miscalculation of staggering proportions. According to these revised theories, the universe could actually be 26.7 billion years old, or possibly even older. If this hypothesis is correct, it means we have made a critical misjudgment about the timeline of the cosmos. While astronomers have long believed they had an accurate measure of the universe's age, the data from Webb is now challenging those deeply held assumptions. Since it began operating, the James Webb Space Telescope has generated a firestorm of controversy, shaking the foundations of astrophysics and thrilling scientists with its discoveries. As new evidence emerges, it is clear that some long-standing theories must be revised, or even discarded entirely. The telescope's ability to peer deep into the universe's past, observing galaxies at extremely high redshifts, has allowed scientists to uncover something truly baffling: galaxies that appear far too massive, structured, and evolved for their supposed place in cosmic history. According to our current models of galaxy formation and cosmology, such galaxies simply should not exist at these early stages of the universe's evolution. This stark contradiction calls into question the accuracy of the lambda cold dark matter, lambda CDM, model, the leading framework for explaining the universe's expansion and structure. The discoveries suggest that we may have a fundamental misunderstanding of the fundamental forces and processes that govern the cosmos. Science is now on the brink of a revolutionary transformation, one that may demand a re-evaluation of everything we thought we knew about the universe. It is possible that we are witnessing the birth of an entirely new branch of physics, a discipline that could alter the very foundation of our understanding. At the heart of this paradigm shift lies the long-overlooked work of Swiss astronomer Fritz Zwicky, whose groundbreaking ideas are now experiencing a resurgence. To comprehend the radical new theories challenging our understanding of the universe's age and structure, we must first revisit the core principles of traditional cosmology. For decades, astronomers have worked under the assumption that the universe began with the Big Bang, an event that marked the sudden expansion of space from an infinitely small and unimaginably hot singularity. This explosive beginning laid the groundwork for everything that followed, from the formation of fundamental particles to the emergence of vast cosmic structures. During the immediate aftermath of the Big Bang, a process known as nucleosynthesis led to the creation of the lightest elements, primarily hydrogen and helium. The universe then entered a period known as the Dark Ages, a time of darkness lasting for hundreds of millions of years before the first stars and galaxies ignited. Over time, gravitational forces gradually pulled matter together, forming the first cosmic structures, which eventually gave rise to the galaxies we observe today. Traditionally, it has been estimated that hydrogen ionization, the process that made the universe transparent to light, began around 400 million years after the Big Bang and concluded roughly a billion years later. It was during this period that the first galaxies and stars are believed to have formed, emitting powerful radiation that ionized the intergalactic medium, and allowed light to travel freely across the cosmos. However, the James Webb Space Telescope has revealed something shocking. Highly structured, luminous galaxies appear to have already existed at this stage, far earlier than previously thought possible. Even more astonishingly, spectral analysis of their light suggests that these galaxies contain a diverse range of stars, some appearing significantly older than expected. This suggests that these galaxies were not composed solely of massive first-generation stars, but instead included stars that had already undergone significant evolution. The presence of these mature galaxies so early in the universe's history defies all previous expectations and calculations. This leads to three astonishing possibilities. The universe is much older than we previously estimated, meaning that the Big Bang must have occurred far earlier than 13.8 billion years ago. Galaxies and stars form far more rapidly than our current theories allow, requiring an overhaul of cosmological models. Some of these galaxies may originate from a parallel universe or a preceding cosmic cycle, raising profound questions about the nature of existence itself. The enigma of galaxy formation has long been a focal point in astrophysics. It has been widely accepted that the earliest galaxies formed during the Ionization epoch, as matter coalesced under the influence of gravity, eventually leading to larger and more complex structures. According to previous models, these young galaxies should have been small, containing mostly massive, short-lived stars with high formation rates that flooded the universe with radiation. Quasars, the ultra-bright cores of distant galaxies powered by supermassive black holes, were believed to have reached their peak approximately 2 to 3 billion years after the Big Bang. But now, James Webb has thrown another curveball, the discovery of 6 supermassive black holes that appear to have existed just 200 million years after the Big Bang. These findings suggest that quasar activity may have peaked much earlier than scientists had assumed. If true, this would mean that the entire timeline of cosmic evolution, spanning the birth of galaxies, the formation of stars, and the heating of the intergalactic medium, has been miscalculated. Another intriguing anomaly concerns the phenomenon of angular expansion, which may be one of the largest sources of observational error for astronomers. Normally, as an object moves farther away, its apparent size decreases. However, at extreme distances, a bizarre effect occurs: the angular size of distant galaxies appears to increase rather than shrink. This phenomenon challenges the standard model of cosmology and suggests that the expansion of the universe may not be as straightforward as once believed. This is where the theories of Fritz Zwicky come into play. A Swiss astronomer working in the early 20th century, Zwicky was a maverick thinker who frequently clashed with the scientific establishment. One of his most controversial ideas, the tired light hypothesis, suggested that the redshift of distant galaxies was not due to the expansion of the universe, but rather to the gradual loss of energy from photons traveling vast cosmic distances. For decades, Zwicky's ideas were largely dismissed in favor of Edwin Hubble's theory of an expanding universe. However, recent observations are forcing scientists to reconsider some of Zwicky's conclusions. A modern researcher, Rajendra Gupta, has revived and expanded upon Zwicky's tired light hypothesis, incorporating new variables such as changing fundamental constants over time. According to Gupta's calculations, if these factors are accounted for, the universe could be at least 26.7 billion years old. If these theories hold true, they would rewrite the history of the cosmos as we know it. Our universe may be far more ancient, intricate, and mysterious than we ever imagined, and the discoveries of the James Webb Space Telescope may only be the beginning of a radical shift in our understanding of reality. Stay tuned for future updates as scientists continue to unravel the biggest mysteries of the universe.